notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC, which became effective in May-June 2018 and is valid currently and will be valid for a number of years more to come. As of December 2025, the syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards. And currently, there are a few pilot projects being conducted in a few Caribbean countries. The content of the syllabus remains unchanged. The two main planned changes at this level are: one, split the exam into two parts, and two, there will no longer be any alternative sections. All sections will be tested. Schedule of videos, as you are aware, these first three sections, made up of 51 videos, have all been completed, and all those videos are on YouTube in their entirety. Please make good use of them. I will scroll through most of this introduction quickly. Right now, we are at 7. This is the 13th of 26 videos, and hopefully I should finish this section by the end of this month. After which, of course, we will do geometry and trigonometry followed by vectors. Please note this disclaimer down here. This schedule is just a projection and it is not to be interpreted as a contract with anybody. As I said, all 33 videos in section 1 have been published. Please make good use of them. You also need to know the times tables 2 to 12, since calculators are not allowed in paper 1. These videos are even applicable in primary schools, especially from this first section. As I said, I will scroll through quickly. Those have been published on YouTube in their entirety from section 4, the others only partially. Section 7, 26 videos. Recommended textbooks. A very good website that will help with the paper 2 questions from CSEC Math. Just a reminder that the formula sheet is provided for CSEC Math examination papers. Print screen from the syllabus. Page 1, all of those have been completed. Page 2, all of those have been completed. Page 3, 10 to 12 have been completed, so we are now at 13. A quick overview of what remains for this section up to objective 17, and then up to objective 20, and then up to objective 22, and finally up to objective 26. That is where we need to reach with this section. So we are back here. These 12 videos have been completed from this section. Those indicated in yellow have been published in their entirety on YouTube. The others are only partially published. We are now at video 13 here, and when this is finished, it will be partially published. So objective 13, and it says, represent the solution of linear inequalities in one variable using, and you have 3 methods here to use: set notation, number line, and graphs. In this video, we will begin with number line as that is easiest. Then we will deal with graphs, and finally with set notation, since that may be a little more difficult to understand and to write than the other two. So to begin with, what is an inequality? Your syllabus, page 62, says that it is any relationship between two quantities indicating that one is strictly less than or less than or equal to the other. Let me rephrase that. An inequality is a relationship between two quantities indicating that one is strictly less than the other, or it is less than or equal to the other. If you are wondering about a relationship between two quantities indicating that one is strictly greater than or equal to the other, those are already implied in the above definition. If A is less than B, then B is greater than A. Example, if 4 is less than 7, then 7 is greater than 4. Before we proceed any further, let's make sure that most of you will never forget the meaning of these two symbols. Students generally confuse them. Which one means less than and which one means more than? Now we know A is less than B, B is greater than A. But many students confuse those two symbols. Consider a child's coloring sketchbook shown at right. Here, let me explain what this is. It shows the top view of a boy wearing brown pants. So this is the head of the boy, that is his face. These are his legs down there under a table. And long blue sleeved shirt. So that's the shirt there that he's wearing, long blue sleeve. He is sitting on a green chair. This is the back of the chair, and you can see part of the chair down here, down there to the side of his legs. At a white desk, this is the desk in front of him, holding an open book on the table. So you understand this picture. His arms are resting on the desk. Consider the shapes that the arms form. This shape here and that shape there. About 90% of the world's population is right-handed, while 10% is left-handed and less than 1% ambidextrous, meaning they could use both hands just as well. So we are dealing with 90% of the world's population that are right-handed. Let's consider this boy's right arm. The shape form is this shape here, this shape here. His right arm, like that, and like that. Now, if you are right-handed, then your right hand or arm is more important to you than your left. You make greater use of it on a regular basis, and because of that, it is even greater in size than your left hand. So this symbol here for right-handed people means is greater than. Anytime you sit at a desk with your right hand or your right arm in this shape, you will remember that the shape so formed, that shape means is greater than. Just look at your right arm. Now let's consider his left arm. It forms this shape here, as we shall see. If you are right-handed, then your left hand or arm is less important to you than your right. You make less use of it on a regular basis, and because of that, it is even Less, that means smaller in size than your right hand. So this symbol here means is less than. Anytime you sit at a desk with your left arm in this shape, you will remember that that shape so formed, this shape here, this shape here, means is less than. Just look at your left arm. Now that is assuming that you are right-handed. Okay? So this holds true for right-handed people only. For the 10% of left-handed people, you will have to learn this using some other method. A suggestion is you can take into account the rest of your classmates, your peers who are right-handed, and say, okay, for them, their right hand is more important, is greater, so I will use that shape. Or you could apply the same logic to yourself, but at the last moment, switch symbol around, maybe. So for me, I'm left-handed, my left arm shape, this shape here, should mean is greater than for me, but for this stupid mathematics rule, that actually means is less than for left-handed people. So however you want to learn that, left-handed people, sorry, but you'd have a little harder time learning this. Now, there are two symbols used for inequality. As you know by now, this one here is greater than, and that one there is less than. These are often combined with an equal sign to give two additional symbols. This one here, it means is greater than or equal to, and this other one here means is less than or equal to. Let's begin with the number line, as this is the easiest, as I said before. So here is a traditional number line. So you solve an equality. Now remember, it's an equation. We are coming to inequality just now. And the answer is y is equal to 4. How do you show that on the number line above? You mark an X or a small solid circle where 4 is located on the number line. And so what you have just shown here is y is equal to 4. What about if you solve that problem and you get y is greater than 4? How do you show that on a number line? We mark a hollow circle at that 4 on the number line and extend a solid arrow to its right. So that's the hollow circle, and this is the solid line extended to its right. That means y is greater than 4. It does not include y. Note, the length of the arrow does not matter. The hollow or open circle means that 4 is not included in the answer. Y is greater than 4. So what about if y is greater than or equal to 4? How do you show that on a number line? This time you would mark a solid circle at 4 on the number line and extend a solid arrow to its right, like this, which means y is greater than or equal to 4.